All right. Hey guys, good morning. So I was not really hoping that this lightning talk will get approved. I was hoping it will get approved for Tuesday session, but it got approved for Wednesday. But anyway, it's good, and talking to you folks. In an environment, most of us are used to tools like traceroute for troubleshooting purposes. We know how to use those tools, but there's a lot of other things that we should remember and know while we are troubleshooting. So we'll see how MPLS OM works. So the packet format, the 3 or 4 components that we need to look for is the version number, message type, and I focus more likely on the reply code. In this, we have the message type as the MPLS echo request or the echo reply. And on the reply mode, you have options like do not reply with UDP packet or UDP with router alert, wherein the process is not, or the packet is not hardware switched, instead it's processed by the software. And then you have the reply with the application level control. So if you have an application that understands those packets, it'll use those to respond. The important things that you need to understand from the TTL perspective for MPLS packets is if you have a TTL packet, if an IP packet is coming in with a TTL value of X, the TTL value will be copied onto the next, or the MPLS packet itself, with one value less than X, that is X minus 1. If the TTL value is 0, then it does not forward the packet. It neither strips off the label or neither forwards it an IP packet. So those are a couple of things that you need to remember while you're using MPLS trace or MPLS OM packets. Now, how do we use it? You can use, this is an example on Cisco platforms using ping MPLS IPv4, and you're done. Well, you can use verbose and different other options to see how the MPLS work. This will verify your LSP is completed. Your LSP is complete throughout the path from edge node to the destination where you're pinging. If it's not, you will see failures and the different return codes at different hops. But this is not it. We'll see an example. I mean, with ping, you actually check if your FEC is working fine or not. With traceroute, you actually go hop by hop and see how it's working, or if MPLS enabled or not, and if anything is blocking or not. So we'll take a quick example of this topology where we have two P routers, P1 and P2, IP 1111 and 1.1.1.2, and you have C routers. You have VPN labels on both the P routers and the core having the IGP labels for both the P nodes for the forwarding perspective. And what happens when you trace route in the MPLS network? First, the IP packet comes in with TTL value 1. First time, it'll get dropped. Then the next time, it's TTL value of 2. That TTL value is copied to the MPLS label, and with 1 subtracted, that is TTL value of 1. But now when the packet moves forward after the P router, it will be TTL value 0. And remember, it's not forward. So what happens is the TTL value for the next label goes to 255. But at this time, it says TTL value exceeded because the TTL value was 1, and now it's back to 255. Packet is then forwarded. Now remember, usually what happens when you have a TTL value exceeded, it goes back to the source. But the ping was initiated by the C router. So instead of sending it back to the source, it will be forwarded across so that it can be forwarded back from the remote C router. The reason being, you do not know, or you do not have control or access to the prefixes in the service provider core network. So outgoing label, you have aggregate, and IP lookup is done in the VRF. On the return side, the TTL value is decremented, 255 to 254. The same as the next hop. But remember, the packet, the underlying packet was initially UDP packet, and now it's just ICMP TTL exceeded. And the return goes back to the originating router or the C router where the ping was initiated. Now, during this course, you might have noticed a few things. So, as I said again, instead of the original UDP packet, you have TTL exceeded. The ICMP messages are exchanged with the experimental bit or IP precedence bit of 6. And I also explained the reason for all the trace routes initiated and the message is being forwarded to the C router when the TTL value exceeds. Now what happens is, when you trace route, you do not want, from your service provider perspective, you do not want those nodes in the middle of your network to be shown to the external C routers. So what you can actually hide them using one single command, that is, do not propagate the TTL to the C routers. And you can configure this on the P side. What happens is, if you look at the normal trace route, you will see that the trace route traverses through the local P router, the core router, and the remote P, and then the remote C. But if you configure this command, you will see that the core router is missing from the trace route. And that's what you want to, I mean, this is an example where you have just one core node, but you might have tens and multiple nodes which you want to hide from the external users. How does this work? So in this, when you send a packet, you have the same VPN label and the IGP label. But this time, instead of copying the TTL value from the IP packet and reducing it by 1, it just says the TTL value to 255. Now, the next packet, when it moves forward and strips off the IGP label because of the PHP, it copies the TTL value, 1 subtracted to 54. And now look at this. The funny thing is, in normal trace, you used to have TTL exceeded ICMP messages. Here, since the TTL didn't exceed, you're forwarding your UDP packets. It reaches the C router, and C router thinks who is using the UDP port number, whatever the random port number is used when initiating the trace route. It doesn't find that. It replies ICMP port unreachable. So the reply packets, even if you do a Wireshark to trace out the packets and see what's going on, you'll see ICMP unreachables instead of TTL exceeded. And the flow continues throughout the end from the C to back towards the source C router. So this was a quick walkthrough of how MPLS OM works. Thank you.
We could just hold off questions to the end. We may have some opportunity for Q&A. Next up is Hibernia Networks, peering automation system.
All right. Good morning, everybody. Thank you for having me here. My name is Michael de Boer. I'm with Hibernia Networks IP team. And I would like to show you one of the many tools we have and we use on a day-to-day basis. This one is called the peering management system. After this presentation, I would like to share it with you. So I hope you like it. No, actually, the question is, why do we do what we do? So as a network, we are present on a dozen of IXs, and we get related tickets regarding to peering every day, augment requests, remove peers, change prefix limits, or update MD5s. And we actually want our NOC to be able to do all this, not by logging into the router, but to have like a graphical user interface they can click in and they can actually manage the peers easily. So to do this, we built the peering management system. And despite we track all the peers automatically, we also we have the tools to track all our peers. But the peering management system doesn't really have a backend, since the routers are the backend. So how did we build this? We use a lot of Python. We use Flask as a web framework, netconfig to pull the configuration from the router, and then we rely heavily on the PeeringDB API. JNinja for templating and Picendo 3 for templates. So I would like to show it to you now. This is the peering management system. It actually works really simple. On the first tab, in the configuration file, you can add a router. You give the vendor password for that router, and it will show up in the drop-down menu you see on the left. You click it, it'll automatically log into that router, parse the configuration, which is retrieved with netconf, and then it will automatically figure out your AS number. It will get your name from PeeringDB, because we know the AS number, and then it will also try to figure out on which axis you are present for that specific router. In this case, that's Equinix Dallas. And then you can just choose if you want to show the configured peers or the not configured peers. So here you see an example. You see the description of the peers, the ASN of the peers, the IPs. We got some action you can do. The envelope will actually just render an email which you can send to the party you would like to peer with. It automatically build the email based on a template, and it will automatically find all the relevant email addresses in PeeringDB for you. And if you decide to peer with them, you can just, well, yeah, this is the template. Generate it automatically. And if you want, if you choose to peer with them, you can just, well, fill in your max prefix limit, or you could just use the prefix limit you have on your peer group, for example. Fill in an MD5 password if you like, and then click the relevant peer group, and it will automatically add it to the router. So this is actually what you see in the background. This router, edge1.dal1.us, for us is a Juniper router. It will build the set command based on a template, set protocols, BGP. Group IX Equinix, so the peer group was retrieved automatically. The neighbor, the peer AS authentication key we want to fill in, and then the max prefix limit. It's sending that to the router using netconf. It updates the cache of the application, and then, well, you actually see just the HTTP GET to render the next page, showing you that the peer is configured. And you can go back and do that trick a couple more times. Fun thing to note is also that this will kind of work pretty good on your cell phone as well. Here we are updating that same peer prefix limit. We'll set it to 900. You'll actually see the MD5 is configured now. You can see that by the string in the MD5 field. So we want to update it to 900 now. And, well, it does the same trick in the background with the set command, deploying it on the router. Yeah, this is the unconfiguring. Great. So it's deleting is actually the same as deploying them. So can you use this as well? Yes, sure, of course you can. I will upload the code on GitHub in 5 minutes or after Willem's presentation, so it might be a bit longer. If you have any questions, let me know or talk to me offline. Thank you very much.
Our final talk is going to be Stubby, DNS privacy and security and daemon for everyone. And we should have a few minutes for questions afterwards. Thank you.
Yes, so this is Stubby. My name is Willem Torop from NLNet Labs. Stubby is a privacy and security daemon for your endpoint. So Stubby originated from the development work on getdns. And getdns itself originated from the IETF. There was some discontent with the application developers at the IETF with the state of the DNS libraries. They said those DNS libraries are made by and for DNS people and not for application developers. So they decided we create our own specification. And that became the DNS API specification. It's a specification for resolving, for DNS resolution, so looking up names. It's asynchronous, designed by and for application developers. Then Alison Menkin, at that time working at VeriSign Labs, took up the initiative to create an implementation of that specification, and she involved NLNet Labs, for which I work, and some other parties. And currently, many people have worked on getDNS. And well, so here are some features of getDNS. So in DNS, you have 3 components. There's the stub resolver, which is the library in your end system that answers DNS questions for your applications. The stub resolver usually forwards it to the full recursive caching resolver in your network, work, or somewhere else. And that recursive resolver in turn consults the authoritative name servers that serve the zones. Now, authoritative name servers, they can return delegations to other authoritative name servers that a full recursive then follows. So getdns acts as a step resolver, but can also do the full recursion. What used to be quite unique about getdns is that it can do DNSSEC validation while acting as a step resolver. Currently, there are actually 2 more step resolvers that can do this. But what is unique about getdns is that to do this, to do DNSSEC validation and step resolution, your recursive resolver has to be DNSSEC aware. So sometimes those recursive resolvers are not DNSSEC aware, or even worse, they almost actively try to hamper DNSSEC. And so getdns uses a method or has a feature also developed on the DNSSEC IETF, which is called DNSSEC roadblock avoidance, which basically means that if all else fails, it will fall back to full recursion to do the DNSSEC, to fetch the DNSSEC data it needs to do its validation. What's new since last IETF is DNS 6.4. So if you have a IPv6 only environment, it usually has 2 components, NOT 6.4 and DNS 6.4, to let those IPv6 only endpoints also connect to IPv4 hosts. The NOT 6.4 component translates IPv6 addresses to IPv4 addresses, so destination NOT, and the synthesized IPv6 addresses are provided to the end hosts by DNS 6.4. So what DNS 6.4 recursive resolver does basically is it looks up a name. If it does not find a quad A record, no IPv6 address, it synthesizes one that can be used in the IPv6 only network. So this is problematic for DNSSEC. If you have a host that is IPv4 only, but is DNSSEC signed, because the end host will receive a synthesized answer, which is not DNSSEC valid, which is not authentic. So getdns can work around that by doing its own synthesis. So getdns also has many features and is actually developed alongside the development of privacy for DNS. So there have been privacy for DNS is basically what it turned out to be is DNS over TLS, but there have been many improvements to do DNS over stateful transport. For example, it pipelines DNS queries over the same TLS session, and it has parameters to time out. And there's a draft about ways to authenticate the TLS session and also eDNS zero padding. So getDNS has lots and lots and lots of more features, which I'm not going to talk about, but these features are actually interesting for any application, right? It would be nice if any application on your system could use getDNS as a resolver, stub resolver, with these features. So while developing getDNS, we have this tool, getDNS Query, which can use all the features that are available in getDNS. It's also used in creating unit tests. And also, since the 1.1 or the first alpha release for 1.1, getDNS can do request handling, so it can actually act as a little server. So, this was the state of getDNS. You have all these nice features that are very nice to have for any application. There was this getDNS query tool that can use them all. getDNS query can also do request handling, which is new in getDNS 1.1 Alpha 1. So getDNS query could act as a local stub resolver to provide all those things for any application on your system. So that's what Stubby is. Stubby is just getDNS query, but with a different name. It's actually installed with a different name too. And it behaves a little bit different than the default getDNS query. So this is how you build it. It's the usual get, configure, make, install. So note that, so in the coming examples for Stubby, Stubby is configured as a privacy DNS local server. So here on configure, I provide a few options that build Stubby with minimal dependencies. So it says enable stub only, which releases the dependency on lib unbound, and also IDN is not important because it's a local resolver. Okay. So Stubby also reads config files. So it defaults by listening on the loopback device, which can be altered by config files. But here are a few example configuration files. The first one is an example of how to configure DNS over TLS opportunistic. That means that the TLS connection is not actually authenticated, but it's still it's private, right? So you cannot. It's not possible to sniff the queries you are sending. Below that, there's the strict authentication for TLS simply by providing the name. By the way, the opportunistic authentication config file uses the DNS privacy service provided by DNS.org, which might be the best performing privacy DNS service here. The lower one uses the NLNet Lab server. This is another authentication mechanism by pin set, because for a resolver, lack of interaction might want you to authenticate by certificate by the public key used instead of how it is signed and what name it uses. So Stubby actually has, since it is getDNS query, has all the command line options getDNS query also has, which are many. So you could simply run Stubby with DNSSEC validation enabled as well by providing the plus DNSSEC return status option. But there's one option specific to Stubby, which is -G, which runs it into a background mode. So once you run Stubby, you should validate that it works by sending it a query. And then you might modify your upstream resolvers to use Stubby instead of the upstream resolvers provided by the network directly. So Stubby is still alpha. We will have a stable release for getDNS 1.1 before the end of the year. Though we will probably also release a more stable Stubby. So I've been using Stubby now since the DNS.org this weekend without any problems with the opportunistic TLS. With authenticated or strict TLS, then you might encounter some problems still. But we will work on that and re-release a new version of getDNS with a fixed Stubby. So we came up with the name Stubby because it's sort of catchy. And then John Dickinson, one of the developers of getDNS, discovered that there's actually a American World War I war hero dog called Stubby, Sergeant Stubby. And so we use him as our mascot now. That's Stubby. Thank you.
Looks like we've got a couple minutes for Q&A if anyone has any questions for our speakers.
Matt Petak, Yahoo. For the person doing the peering tool, looks awesome. I was a little curious, so if your router is your back end, you put in an MD5 password for somebody's peering session, it goes onto the router. It looks like when you pulled it back up, all you have access to at that point is the encrypted string. You lose access to what the unencrypted MD5 string is. Is that correct?
You might be right.
Have you run into a situation where they say, can you apply the same string that we had on that other router over here, and you're kind of going, I don't know what that string was anymore?
Usually when we augment peers, the peer will give us the new MD5 they want to use on that one. So I didn't run into it, but that's a good point.
Okay, thank you.
Julian Goodwin, Google, also for the peering automation question. Interesting that you looked at, it appears you configure individual sessions individually, not have a standard configuration. Most networks I peer with, as Google, seem to have consistency, and we generally find that where there's exceptions, they're usually errors.
I'm not sure if I understand what you mean. You mean...
So you had the prefix limit listed for each individual session instead of just the prefix limit for the peer?
Yeah, well, what we personally do, we set prefix limits on the entire peer group, and then for every individual peer who wants something different, we alter that peer on peer-by-peer basis. This is the tool we built. It works, but we can also add a lot of features. So I want to encourage you to help me out, and that would be a nice feature to add.
Special thank you to all of our speakers today.